We were looking at block diagrams for control systems, and we showed how to use algebra. I mean, what we're trying to do is find an overall transfer function from a block diagram that's composed of multiple components. Each little component has its own little transfer function. So one way to go about this is we sort of pre-do the algebra and we manipulate it, the diagram itself. Let's say this guy, for some reason, we would like to have this signal moved behind or to the other side of this little transfer function. Well, the way to do that is this: we would need to divide by g on this way back and see what this x2 is just g times x1. And what x1 is, of course, x1. But if I take x2 and then divide by g, well, x2 was g times x1. So if I multiply by g and divide by g, I get back x1. So I can move this guy to the right of that process by dividing by g on the way back. And let's say this guy. Let's say we'd like to move this gain to the other side of this comparator. We move the g over there, but we have to divide by g on this guy here. Convince yourself algebraically that that's okay to do. And there's a whole bunch of block diagram manipulations that you could sort of pre-confirm by using the algebra we've already been through. We already talked about this one. Gains in series, rather. You just multiply them. Here I go the other way. I'd like to move this gain in front of the comparator. So I would have to multiply this signal here by g to make it come out right. If I move this g over there, I got to put a g down here. Convince yourself of the algebra of that. I'm not going to go through each of these. If you look at the left side and the right side and do that little bit of algebra, you'll convince yourself, you should convince yourself that these are equivalent block diagrams. You get the same resulting signals. And here's one. You could have more than two signals come into a comparator. You could break it up into two comparators or more. Let's go through an example. We'll say this is our beginning block diagram, and we want to get to the overall transfer function output over input, output y over input x. So let's do this in steps. First, see that this is our little inner feedback loop. We have a g forward path, a feedback path, the comparator here. That's a plus there, so it's going to be a minus there. Normally it looks, when we have a minus sign on the feedback loop, it's g over 1 plus gh. Since it's a plus here, it's the opposite sign. So it's g1 over 1 plus g1, 1 minus g1 times h1. So this little block replaces this inner loop. That's all we did in that step. The rest of this is the same. You know, this signal going into H2 is the output of this inner loop. So this top one is where we just left off. The next thing we'll do is we just want to move this pickoff from in front of G2 to after G2. To do that, we need to divide this H2 by G2. That's all we did there. So we moved this from left of G2 to the right of G2 by dividing by G2. That's all we did there. Here's where we left off. Here are two gains in series, so they just multiply. Here are two gains in parallel, so they just add. And that's all we did there. We're almost done. Here's where we left off. And here we have another inner loop, this time with a negative sign. So this plays the role of G. This plays the role of H. You have a G over 1 plus GH. This inner loop is in series with this guy. So those two things get multiplied. Simplify it out a little bit, and here is the overall transfer function from input X to output Y. You can see these things get a little tedious. You'd have to keep redrawing. You're either stuck with doing a lot of algebra or redrawing a lot of block diagrams. So you can see it gets tedious. We'll talk about an easier way when you have really complicated block diagrams. It's going to be called Mason's rule. We'll get into that a little bit later. So far, we have basic block diagram algebra where you label the signals and do like the algebra of it, which normally amounts to sort of multiple equations and multiple signals or unknowns, where you want to get it all in terms of only the output and input. Get rid of intermediate signals. Anyway, we did an example of that earlier. And I think I'll stop it there for now. We'll cover more. We're not done with block diagrams and Mason's rule and signal flow graphs.